Good morning, everyone. Myself, Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we have discussed about the subject on W3601 protection and switchgear for 2021 regulations. In this presentation, I introduce the topic static relays. It includes context for the presentation power system protection. It also identifies the presenter and post information. Introduction. Static relays do not have any moving mechanical parts. They use electronic circuits for operation instead of coils and magnets. These relays were introduced in 1960s. They provide better performance compared to traditional relays. Static relays. Static relays employs solid-state devices such as transistors and diodes to measure or compare electrical parameters. Its circuitry is engineered to generate an output signal that triggers a trip action once certain threshold conditions are met. This output activates a tripping mechanism which can be either electromagnetic or electronic in nature. Unlike traditional electromagnetic relays that rely on moving parts, static relays perform equivalent functions through electronic control circuits, offering enhanced reliability and precision. Operating principle. So static relays use solid-state devices like the transistors and diodes. They measure electrical quantities and compare them with preset values. When the threshold is exceeded, a trip signal is generated. This signal activates the circuit breaker. Components of static relay. The main components include current transformer, potential transformer, rectifiers, and the measuring unit. The input signal is taken from the power system. The rectifier converts AC signal into DC form, and the processed signal is then analyzed for fault detection. Working process. Working of static relays. The input signal is rectified and compared with a preset value. The signal exceeds the limit, it is amplified. The amplified signal activates the output device. This results in tripping of the circuit breakers. Advantages of static relays. Static relays consume less power and offer higher frequency. Then they operate faster and have long life. They are reliable and resistance to shocks. Then they also provide high sensitivity and reduce false tripping. And the the uninterrupted tripping is greatly minimized. Unlike some devices, static relays are free from issues related to thermal storage. By amplifying input signal, these relays boost sensitivity significantly. Then disadvantages of static relays. Static relays require on uh, external DC supply. They are sensitive to electromagnetic interference, and it requires their design is less durable and may be fragile, and then voltage spikes can affect the performance. Applications of static relays. Static relays are used in EHV AC transmission line protection through advanced distant protection techniques. They are applied in overcurrent and earth fault protection. They are also used in differential protection schemes, and these relays ensures system safety and reliability. Limitations of static relays. Static relay components are highly vulnerable to electrostatic discharge, which involves sudden electron transfers between the charged bodies. To prevent the damage, these parts require specialist maintenance to shield them from such discharge. Then, high voltage surges can easily disrupt the relays operations, so the protective measures must be implemented to guard against voltage spikes. Then, the relay's performance is heavily reliant on its electrical components, and it has a limited capacity to handle overload conditions. Then, compared to electromagnetic relays, and the static relays come with a higher price tag. So, the relays design is susceptible to inference from the surrounding environment, which can affect its functionality. Then, instantaneous overcurrent relay. This relay operates immediately when current exceeds a set value. There is no intentional time delay in operation. It depends on only on current magnitude. So it provides very fast protection. Working of instantaneous relay. The relays trips when the current exceeds pickup value. So the operation time is very short. That means less than 0.1 second. Its response time remains fixed and does not vary. Uh, Coordination among definite current relays on the variation of fault current, which changes based on the fault's location due to differing impedance between the fault point and the power sources. And then relays settings vary depending on the location in the system. Coordination is based on fault current levels. Conclusion. Relays are essential for protecting power systems, and then static relays improve safety and reliability. They help isolate faults quickly. They prevent damage to equipment and ensure smooth operations. These slides list the sources used for preparation. It includes textbooks and IEEE papers. These references provide detailed understanding of static relays. It adds credibility to the presentation. Thank you. Marks the end of the presentation. It is used to thank the audience. It may also invite questions. It concludes the session. Thank you.